All right, so we're practice quiz 6.5 to 6.9. I think number one is about 15% and 100,000. Is that what you're looking at, everybody? So if anybody's watching this video and number one isn't about 15% and 100,000, turn the video off and wait till that sheet comes up. This is usually the second practice quiz that I do in sequence. I don't have a video yet from the first one because reasons. But number one, we're hoping for 4.96 years. We're hoping for 108,365,744 if we round to the nearest person. Two, we're hoping for 6.39 years and $3,338.31 if we round it to dollars and cents. Three, we're hoping for 696.6 if you want to go a decimal place, or 697 if you want to round it to the nearest amount of days. Those would both be understandable to me because you can have part of a day, but if you don't want to round it or do want to round it, whatever. Can I help you? 1, 2, 3.
Number one.
Number one. Did you start off with 1.15 equals?
Yes.
E to the K?
Yeah.
K is roughly a 0.139 stuff.
Is it just e to the k and no t?
The T is a 1.
Oh, okay.
Because it's 1, it says in a given year. So the initial T
So
is
it's
a
just
1.
that you just do the ln of 1.15.
Correct.
Okay. That'll have me.
Okay.
That should fix.
All right. More front page. Anything to get anything started?
What's the equation look like to get the 108 million?
I used 100,000 starting from now, e to a 50 year in the future times the K that I would have stored somewhere. That might seem like a ridiculous population, which it possibly is, but that's what the math did. If you remember from any time we've ever studied interest, if you have 15% for 50 years, crazy stuff happens. That's to some degree how the wealthy got wealthy, is by just letting their money do stuff like that population did.
What was the second answer to number one?
108 million,
Okay. Yeah.
and a bunch of other numbers.
Okay. Number two, probably have the same mistake.
So,
It would be 1.08.
no.
No.
Interest works differently. The
Okay.
0.08 is the K. You don't find K. For the
Okay.
interest ones, 0.08 is the K, and you just jump right into it. So your first equation would use the 1500, the 2500, the 0.08, and you're hunting a T. And then the second problem, you use the 1500 and the 0.08 again, but you're using a 10 to go find a money count. More page ones.
Hang on. Wait.
Hang on, wait.
Let me get this answer, and then
Okay.
I need you to.
Anything anybody wants to talk about where we're in slight waiting mode?
What was the answer for the first one?
6.39.
What was I doing wrong?
Do you have 2500
wait,
first?
Hang on. What'd you say?
Do you have 2500 first before
Yeah.
the equals? That should take you down a path to 6.39.
I punched it in wrong.
Okay.
Instead of saying divide 0.08, I just hit 0.08.
Okay.
I think I did that too.
More page one, anything?
I think it's 6.4 ish. Like 6.3.
Yeah, 6.39, that's what I put.
Yeah. And then what do we do after, like, for the second one?
Then you need a whole new problem.
Okay.
So reuse the 1500, reuse the 8%, but it's 10 years is now known, and you
Okay.
don't know the future money. More page 1?
Like 3338.
Yep.
Okay.
Number 1 would be a 2-point question, 2 would be a 2-point question, 3 is just a 1-point question. Turn to the page. Good. 4, we're hoping for 6,566, and if you want to go a decimal, 0.4 years. It makes sense to go the part of a year, I think, because you can have part of a year of time, but it also, if you round it to a whole number, I'm not going to object to that. 5 is a fourth. 6, the closest thing I would have been to putting is infinity, but it does not have an answer because there's a little bit of a crisis about not being able to know whether it's positive or negative. If on the problem I had a 0 with a little plus or a 0 with a little minus, then that probably would have been answerable, but a two-sided limit is what that's called. It could go either way, so we can't commit. 7's infinity. 8 has the same crisis that 6 did. I'm sure I didn't mean to do that twice. I was probably just making up problems, and I don't know that the test would have any with no answers, but the closest thing you have to an answer on 8 would also be infinity. So if you had infinity, you're probably in the right thought process. But again, you can't decide on the sign because it's a two-sided problem, and it really could go either way depending on whether we're more or less than 0. 9 is an E. If you had a 1, you did a lot of good math probably, but you have to start off the problem with doing an ln, and then you finish the problem by taking e to a power, and that power is a 1, so I just wrote E. 10 is a 0, 11 is a 1. Brief synopsis of this: you have to have a fraction, one fraction, before you do this rule. And the way you create a fraction on 8 is by making a common denominator, which always creates the product rule having to happen to L'Hopital's rule. And 9, you create a fraction by doing an ln first to move the power around, and then have to pay for that with an e later. Question about the details of any of that after that overview.
So how do you spell that?
Which one?
9.
9, you do ln in front of the problem. That would let you do what with powers when we have ln's, anybody?
Move it to the front.
Move it to the front. And instead of writing it as 1 over ln x in front, and this other ln x we created being over 1, just mash that together as a single fraction. And that single fraction is 1. It's ln x over ln x, which is 1. And you don't even have to do anything with the rule or anything, just the answer is temporarily 1. Then you have to remember, wait, I did that ln, I have to pay for that eventually, so it's e to the 1. Rewind that at all, anybody? Usually that's the problem, that we have to do derivatives and it takes on the shape that I refer to as a Christmas tree kind of shape. But this time it went a little bit quicker. Yesterday definitely went Christmas tree.
Number 10.
Number 10, do the derivative on top, do the derivative on the bottom. If you plug in, it'll still be 0 over 0.
Yeah.
So what
So
do we
go
do?
again.
Go again. What do you have for the next derivative on the top then?
6x.
Agreed. Bottom.
Negative cosine 2x.
There's numbers in front that build, because when you're doing the derivative, the chain rule keeps giving you, at first it's
So it's
2,
4
and now we're up to
in front of
4.
the cosine?
Yes,
And that is negative, correct?
it is. But the negative, and really even the 4, it didn't matter, but it is negative 4 cosine 2x. Now we plug in 0, and the top is 0, but the bottom's 1.
Okay.
Well, cosine 2x is 1. It's really, the bottom's negative 4, but since the top is 0, it
It's
didn't even really
0.
matter. If you had done the derivative wrong on the bottom, you'd have
Okay.
gotten away with it, because 0 is what we are hunting. More to 11. 12 is picture-based. What's your missing side?
The bottom,
Yeah, what is it
did
though?
A,
Yeah, but number.
Route 55.
Root 55 is correct. So sine ends up being 3/8. If you don't get the sine right of 3/8, that's a relatively big problem. Because that's what I gave you to start with. So if you drew a picture and that has changed, you really need to revisit your picture in a major way. Cosine is that root 55 over 8. Tan would be 3 on top of root 55. Looks like on this sheet I didn't fix it because the book all chapter hasn't cared, so I guess I temporarily lost my motivation to fix roots on the bottom. Cosecant is 8/3. Secant is 8 on top of the root. Cotan is root on top of 3. 13's life, it's chart for a little bit. Root 3 over 2, 2, negative. Either 1 over root 3 the way they've been doing it, or root 3 over 3 the way we've more done that in our life together through trig and into this day. 16's a 1. Lots of stuff happening in 16, like 4 or 5 different math steps at least. 17, you'd have to draw a picture and you end up with a fraction that has a root on top of x. The root under the root is 25 plus x squared from you creating a hypotenuse on your picture. Can I help you?
17.
17. Do you have a picture?
Yeah.
Okay. What did you hypotenuse of a square root of 25 plus x squared? Does that make sense?
I see where I was wrong then.
Okay.
Okay.
Anybody else?
So then,
So the cotan from in the parentheses helped you draw the picture of legs 5 and x, hypotenuse, crazy root. Then from that picture you try to create a secant, which is cosine's cousin.
yeah.
So cosine would be the x over the root, but then flipped. So root over x.
So the root 25 plus x squared over x.
Correct.
Okay.
More to 17 page.
For number 12, do you want us to write the sign again?
No, I guess I don't care. By the way the instructions said, it said find the other 5.
Okay.
So yeah, you wouldn't need to write that back. That was a 3-point question there because it asked for a lot of stuff. 18 page. Make sure your card has the right formulas to do this page. 22, debatable whether you want to rewrite that with a negative power and algebra be good at rewriting it so it doesn't have negative powers inside fractions, or flip it, do a sign problem, but that's going to have fractions, and then algebra be good at getting rid of fractions in fractions. But they mean the same thing. Negative powers in fractions are fractions in fractions, and that's none of that's your friend. If you get 19 right, you got rid of fractions in fractions, so maybe that's the way you want to do 22 if 22 was troublesome, getting rid of the negative powers. Toss up. You've got to figure out where your algebra preference is and what you're better dealing with. 18 is a simpler one. 18 is negative because it was a co. 5x to the 4th on top. A root on the bottom. 1 minus x to the 10th. No real tricks there. 19, the initial build is going to have a fraction on the top and a fraction on the bottom. And a negative because it's a co. And then you have to get rid of the fractions in fractions with your algebra skills. Best answer is negative, and then on top a 6, on the bottom an x squared plus 36. And maybe we need to talk about how the fractions died. 20 is definitely a 1 on the top, definitely a 2 on the bottom of the final answer, but it's going to take a little bit of algebra manipulation to get there. And then on the bottom, you could either have 2 roots that didn't multiply each other yet, one of them being a root x plus 3, the other being a root that has negative x minus 2. Or you could FOIL out those roots if you want, and I have that answer if you did it, but I don't care if you do that. Does anybody want the answer if you FOILed the 2 roots out? Okay. 21 has no real tricks. 21 has e to the x on top. The bottom has e to the 2x plus 1. If you were adding in an opposite order, no harm done. 22 is going to have some tricks because you either ran through a space where you have negative exponents everywhere, or you ran through a space where you have fractions everywhere. If you fix them, they go to the same thing, but it's going to take some work, and it might take 2 different explanations for the 2 different paths if we took 2 different paths. Answer 22 is going to have 2x on top, a root on the bottom with 9 minus x to the 4. 23 has one very mild cleanup trick, which is canceling 5s. There should be a 5 on the top. There should be a 5x in bars on the bottom. But the 5 in bars on the bottom doesn't need to really be in bars because it's a positive number, and those 5s can just be ditched. So best answer on that one is 1 on top, x in bars on the bottom, and then under a root 25x squared minus 1. Let's take on simpler ones first if we need to build momentum. Anybody need the 18, 21, 23 guidance? Then mean ones? Mean one algebra guidance, trying to get it to the finish line?
22.
Okay, so 22, do you want to live with the negative powers, or do you want to
was
flip
doing
it and live with
fractions.
fractions? Okay, so if you're doing fractions,
X squared over 3.
we'd have, yeah, or 1/3 x squared if you prefer.
Yeah.
So the derivative for the top of that way would be a 2/3 x.
Yeah.
In the long term, I'm going to leave the 2 and the x up there and just scoot the 3 to the bottom.
Yeah.
Then under a root, I have 1 minus a 9th x to the 4.
Okay. Yeah.
Okay. So what we don't want to have is that 1/9.
Yeah.
So I'm going to have to multiply by 9 where the root is.
Okay.
So what that's going to do is leave the 3 untouched. Under the root, 1 becomes 9, 1/9 dies, and x to the 4th just waits.
Okay.
Then we have to, what we did to the bottom, do to the top, but make sure you're not too tunnel visioned and you're looking big picture. Bottom didn't truly multiply by 9 because it was under the root that we attacked.
Yeah.
We truly multiplied by 3.
Okay.
So
then
if
it
we
just
multiply the
cancels
top
3.
by 3, that's going to either make the 2 a 6 that can cancel the 3, or it's just going to cancel the 3. So left standing at the final tally,
Okay.
2x on top, root on the bottom.
Yeah.
That makes sense that way?
Yeah.
I would just travel that path then if you're comfortable with that, because then you're probably also comfortable with 19. And just
Yeah.
kill fractions and don't worry even about how you kill negative powers. Because it's a little different, like
Well,
mentality.
For that one, I did. I still I flipped it to tan. So it'd be
No,
like-
but I mean, there are no negative. The only one with negative exponents is 22.
But if you flip 19 to tan, wouldn't that be a 6x?
Then
to
it
the
would be
-1?
then it would be
That's
negative
what
exponents.
that's what I mean. Is I said I
Okay.
did that.
You might be better to not flip that one.
Okay. Is it still just the same process? but
It'll
make it
be
negative?
yeah, it'll be the same process, but not with a root in it. So like 22, we multiplied by 9.
I mean, like the same process as the card, except
Yeah, yeah, yeah,
it's just negative.
yeah. But like 22 is actually harder because we multiplied by 9.
Yeah.
But really 3.
Yeah.
When you go to do 19, you're going to multiply by actually the same number.
Yeah.
Like everywhere, because there's not a root to like make you look big picture.
Yeah.
More on that page, the algebra details of how to get from where the card drops you to where algebra desires. 20. So I'm going to go on top, I'm going to do the derivative to be half x plus 3 in parentheses to a negative half for a second. You with that?
Yeah.
Then the bottom's going to go 1 minus, and then wrap parentheses around x plus 3. Because it's got to go 1 minus all of that.
Okay.
You with that?
Yeah.
I'm going to attack under the root first, just because that's where we're already looking. If we distribute that negative through the parentheses, 1 minus x minus 2, small cleanup, that's under a root negative x minus 2.
Okay.
You with that?
Yep.
Then for that half on top, we created, I would leave a 1 up there and just scooch a 2 to the bottom. You with that?
Yep.
Then we had parentheses to the negative half, so I'm going to put that to the bottom because negative powers flip things. And I'm going to return the root instead of the half. So now I have a root x plus 3 in the bottom next to the root of negative x minus 2. In front of all those roots, I threw that 2. Top is just a 1, and then I walked away.
Okay.
There are other people maybe greedier than me that want to foil those roots. And that's okay. A root can foil another root, but I just don't personally see an advantage in doing that. I understand the argument, you have 1 root instead of 2, but your root is worse. To me, that's a wash.
What was the answer for 19?
Answer to 19 was negative 6 on top, x squared plus 36 on the bottom. I just think if I look at my answer on 20, if I had to plug in, say, 10, would I rather plug in the 10 to the roots being separated, or would I rather plug in the 10 where I've foiled it and now I have to like square and do a bunch of stuff with signs and math? Like, I think it's easier where it sits for 20. Basically, I'm saying I'm right without saying I'm right. Anything to 23. I guess what I'm saying is 2 people could be right, but I think my answer's better, but I understand why people would disagree. But they'd be wrong. 24 page. We make sure your card has the right formulas for these. Make sure you always find the DU. Make sure you always tweak the problem when you're supposed to and have the correct number like in the front, because that's where these problems usually go wrong, is people not checking the DU, not fixing the DU, not paying for the DU with fractions in front, and then that's where we get trouble hit. 24 is a semi-easy tan problem. You just have to fix some 2's and halves. Grand total is 1/10 inverse tan x squared over 5. This whole page is plus seed. I did not make you plug in at all. You're welcome.
Yes.
25 also has payments with 2's and halves and adjustments like that. It's 1/2 inverse sine. And then I just left 2x over root 10 plus c. If that offends you, it can be fixed. I have the fixed answer, but I won't require that of you. I think we have enough things going on this page without worrying about roots on the bottom. 26, if you forgot to pay off with some 3's, it's okay, because the 3's self-correct. You were short a 3, both top and bottom, and that self-fixes. Answer is going to be 1 over root 3, inverse secant, bars at least around an x. I have 3x over root 3 with the x in bars. If the 3 over root 3, you want to fix it, that does fix to root 3, and I do see that as better, but again, I'm not going to require that of you. I think the best answer would have a root 3 and then an x in bars. 27, there's no payments required. It's 1/4 inverse tan x plus 3 over 4. What makes that a challenge is you have to factor by completing the square to make the problem fit. 28, there's always 1 on each sheet that doesn't fit a format, so you pick a U the old-fashioned way. U would be inverse sine, du would be most of the rest of that mess and just get vaporized. Answer will be e to a power of inverse sine of x. 29, you need 3's and 1/3 kind of to counterbalance some stuff. Grand total is 1/12, inverse tan, 3x over 4. 30, that 5 is a distraction. You're going to have to plink that out of the way and just remember to write it on the answer. The answer will have a 5. And then you also have to factor by completing the square again on this one. It is an inverse sine answer, so 5 inverse sine. And then it's x minus 2 on top of a 2. And that's a wrap. Can I do anything to help that page out?
27,930.
Okay, so 27, do you remember how to factor by completing the square?
Yeah.
Okay. Did you get x plus 3 squared?
Yeah.
When you did that turn the 25 into a 16?
That'll do it.
Do you understand how?
Yes.
Okay. You don't need any more?
Probably not.
Okay. More? Especially for our quiet partners in the middle. The people on the ends are driving the conversation
28.
today. 28. So we'll pick a u to be inverse sine.
Yeah.
Follow what your card says for derivative of inverse sine, and it's most of the rest of that mess. It's 1 over that root.
Oh, okay, yeah.
So that problem can be renamed e to the u, which is our favorite problem ever, du.
Okay.
And both the derivative and integral of e to the u is e to the u.
Yeah.
And we just sort of get out of there. E to the, not u anymore, but replace u
The
with inverse sine of x.
inverse Okay.
More?
Wait, still 30.
30. Did you put the negative out to the front?
Yes.
Negative x minus 2 getting squared?
X minus 2?
Because when you factor the negative off the x squared, you'll take the negative off the 4x as well. Okay, then you're with negative parentheses x plus 2 squared? Or negative, excuse me, negative parentheses x minus 2 squared?
Yes.
Yeah, you're with that. Okay, so then to complete that square, you added in a 4,
Yeah.
but not really, because the minus that's distributing in, really that's a value of negative 4 to the big picture.
Yeah.
So
I
a
get it.
positive 4 pays that off.
Yeah, okay.
And I prefer to put my positive 4 before the minus, just to make it look more structurally the way the card looks. Is that good?
Yeah.